Hello everyone, welcome to the MapReduce session. Well, this session is a part of Big Data tutorial series on upGrad. So if you have not watched the previous videos, it is recommended that please refer to them first for the complete understanding of today's session. My name is Rajan Chhetri. I am the instructor for the Big Data program, and in this session, I will be sharing my knowledge and experience about MapReduce programming. So let us start with the agenda first of all. In this video session, we'll be talking about MapReduce framework. We'll be understanding the internals of what exactly is MapReduce and how it works. We'll be discussing about MapReduce lifecycle, which is very important for understanding how MapReduce works. We will be developing a MapReduce application using Eclipse, and I'll be sharing with you how to run those applications on a Hadoop cluster. So let us start with what is MapReduce. MapReduce is the processing component of Hadoop. As you already know, there are two components in Hadoop. One is HDFS, which is related to file system or storage of the data. On the other side, we have a processing component called MapReduce. MapReduce is the processing layer of Hadoop. MapReduce programming model is designed for processing large volumes of data in parallel. How it works? It works by dividing the work into a set of independent tasks basically. You need to put the business logic in the way MapReduce works, and rest things will be taken care by the framework. So exactly how does it works basically? What is distributing the task means? So let me give you a basic example here how it works. In the previous videos, we discussed about the cluster. So how a cluster looks like. So this is a master, and there are some data nodes which are connected to the master. Data nodes are basically the worker nodes. And in the previous video, I also explained that all the data is distributed in these data nodes in the form of a blocks. Now, whenever there is a client who is submitting an application, or you can say a, an, a MapReduce application to the master, now that application will be distributed across all the data nodes wherever the blocks are present which are required by that application. So this master will be distributing the applications across those data nodes. So here you can see that we have the same applications which are running parallelly on multiple data nodes and processing the data which is present locally. Now this local processing of the data by the application is also called data locality. Now there is a phase which is followed by the MapReduce application. So basically, when we write applications using the MapReduce framework, so MapReduce provides us the required libraries which are used to access the data and to process the data. So once we start learning how MapReduce works, basically, the very first thing that is taught to us is basically the phases in a MapReduce application. So it is map and reduce. It is important for us to understand exactly what these phases are. If we fail to understand these phases, it will be near to impossible for us to write the applications. Because whatever the business logic that we put into the MapReduce application, it basically works according to the phases. So the very first thing that we need to understand is these phases. You can also call it the MapReduce anatomy. Now, map and reduce phases are controlled, or you can say these map and reduce phases are defined by the developer. What needs to be done, what is the business logic that needs to be implemented, is defined in these two phases. We can only implement the solutions, or we can only implement the business logic if we understand the map and reduce phase properly. So in the next few minutes, we'll be understanding how these map and reduce phases work. Apart from that, just to add some more knowledge here, there are two more phases which are, you can say, self-executing by nature, and which are not basically, controlled by the developer. So those two phases are shuffle and sort. We will be understanding what these phases are and what they do basically. So as a summary, as a conclusion, MapReduce is basically, it's a framework which is used for writing applications. So it is basically a collection of huge libraries. You can think of MapReduce as a collection of many Java packages. So what exactly is map and reduce? You can think of a map and reduce as you can say, the two phases which works one by one sequentially. So let me give you a very small picture of how these phases work. Suppose if we have some data with us. Now there are two phases, mapper and reducer. You can think of them like a worker. So this data will be read or will be fed to the mapper. So mapper will contain the business logic for computing the data. Now mapper will filter some data based on the given conditions and will produce some subset of the data or some computed data, which will be forwarded to the reducer. Now this reducer will be aggregating the data and will be producing the output. Well, basically, this is a you can say this is a very pretty simple picture of exactly how we can think of how these mappers and reducers work. But let me give you a very precise example of exactly how these map and reduce phases work. Let us look at this flow here. This is exactly same the way this is exactly same what we discussed earlier. So here we have some input data with us. Now this input data will be provided to the mappers. You can see multiple map workers here. So why these are multiple map workers? Because might be there are some multiple data nodes which are working parallelly, and on each data node the map is working. After computing the data after on the basis of the business logic, it is going to produce some intermediate data. Now the same intermediate data will be forwarded to the reducers. Reducers are basically the aggregators which are used for aggregating the data. After all the reducers have produced the output, they're going to produce the output data. Now there are some components apart from mapper and reducer which can also be implemented in a MapReduce programming model, such as combiner, partitioners. Apart from that, we have writables as well. Now, combiners and partitioners are basically the concepts in MapReduce programming which are used to enhance the efficiency of your application. Apart from that, it also helps in utilizing the cluster, to its potential. Writables are basically the concepts in MapReduce which basically allows you to write the data, right, or produce the output or produce the results in a desired format. Now there are some system components which are also there in which are also involved when a MapReduce application is functioning or when it is running, such as master, which is used for submitting the application, the MapReduce application into the cluster. We have splitter. Input splitter is basically for you know dividing the data into smaller blocks of generally 128 MB of size. We can increase this size block size, or we can decrease this block size depending on the requirement or the nature of data. Apart from that, we have output committer. Output committer is one other component of this MapReduce model, which basically is responsible for generating the output. Now, it is not necessary to use all the components which are mentioned here. Some are optional and some play a vital role in the processing. So the information that we have gathered till now, or the information that we have collected, might sound abstract. So let me give you an example here. With this example, it will be easy for us to understand how these MapReduce phases work. So let us start with the example here. This is how the data flow looks like when a MapReduce application is running. So when you execute the MapReduce application, so it is going to follow the mapper and the reducer phases, where the mapper is going to read the data from the input splits. Now these input splits are nothing but the blocks of the data. Now this mapper is going to follow some business logic, and based on that business logic, it is going to produce some subset, or you can say some results, some computed results. Now those results which are generated after the computation of the mapper are going to be submitted into the reducer for the aggregation. And finally, after the aggregation, these reducers are going to produce the output. So let me give you an example here exactly how this is going to work. And for explaining its working, I'm going to give you the Hello World application of MapReduce, which is the word count demonstration. So we will do it theoretically, we'll do a dry run of it, and then we'll execute it practically on the machine. So let us start how the map and reduce phases help us in computing the word count, and let us start with this. So let us start with the word count demonstration in order to understand how the MapReduce application works. So in order to let me explain you exactly like what this application is basically. So suppose I have some data with me, and from that data we are supposed to find the word count. So let me produce some data here. So this is going to be, let's say, cow, 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 and panda. Similarly, I will start with panda, panda, and cow, and this is going to be bear, cow, and bear. All right. So suppose I have got this data with me. So this data is basically representing, it's you can say it's a simulation of the huge data, but for the easier understanding, we are taking this smaller size. Now this data needs to be computed by the MapReduce application, and we are supposed to find the word count. Now how the word count is going to look like? The word count is going to look like this. It's going to be, bear 2. So the frequency or repetition frequency of the bear is 2. Similarly, the repetition frequency of cow is 5. And similarly, the repetition frequency of the panda is 3. So this is the expected output. So I hope you have understood how uh, what kind of output is expected from this data. No, exactly. Once I write a MapReduce application, right? Once the MapReduce application is written and it's coded completely, how this MapReduce application is going to compute this data? That's what we're going to understand. All right. So let us start with the very first phase is and what that first phase is basically, in the very first phase, this data is going to be read, line by line, and this data is going to be converted into a key value pair. So all this data will be converted into a key value pair form. So if you are new to this key value pair form, I suggest please refer to to hash map in Java, let's say. Hash map in Java is a key value based data structure which is used for storing such form of data. So this data will be read by the MapReduce application and it will be converted into a key value pair. Now, what exactly is the key? Key is going to be the byte offset. All right, byte offset. It means the position of the character. So here, 0 is the position of the very first character here, and the value is going to be the whole line. So I'm just repeating here. The value is going to be the whole line here. So it is going to be cow. It's going to be cow once again. It's going to be cow, and then it is going to be panda. That's how it is going to work. Similarly, we are going to count the offset. So somewhere around approx 17. And the value is going to be panda, panda, and cow. So approx offset is 32, and the output is going to value is going to be bear, cow, bear. So this is what we have done. Basically, we have prepared the input for the mapper, right? So basically, this data will be treated as the input for the mapper phase. All right. So once again, I'm repeating here. This data will be treated as the input for the mapper phase. So here, the MapReduce anatomy or the life cycle of a MapReduce phase goes like this. So this is the mapper, and then we have you know then we have shuffle, then it is going to be sort, and then it is going to be reduce. So now we are about to begin the very first phase of the MapReduce application, and that is mapper. So let us start with the mapper phase. Now, what exactly mapper phase does basically? Mapper is basically is going to read this data, all right, and that too line by line. So you need to understand this nature here, right? The mapper is going to read this data line by line here. So you can think a mapper as a map function, right? In a Java application, you can think mapper phase as a map function in a Java application, and here it is going to contain the key. There are two parameters in this function. One is the key, and second is the value. So this is the map function here, and this map function is going to be called for each line one by one. So here you need to observe that how we are visualizing the mapper phase. We are visualizing the mapper phase like a map function in Java. So map function is called for each line in the given data. For each line, the map function will be invoked separately. In map function, there are two parameters. One is the key and one is the value. Now this key parameter is going to hold the key for that particular line, and this value parameter is going to contain the whole line as the value. Now, in case, yeah, so yeah, obviously, like you are very new to, MapReduce application. So I would like to tell you that these are the Hadoop data types: long writable, which is the uh, long equivalent in Java. So in Java we have long. So in Hadoop we generally do not use the long, when computing the big data. So instead of long, we have its Hadoop version, which is called long writable. Now they are more efficient in terms of serialization. And similarly, we have the text, which is the string version of Java. So text is basically the string, and long writable is basically the long data type. So this map function will be invoked a total of 3 times for this line, and for this line. And in each call, this key and value is going to be the keys here and the values here. So I hope you are understanding exactly how this map phase works and how it basically reads the data, and that is basically line by line. So if I show you the clear picture of how a map function looks like, so let me show you the map function here. This is exactly the same function, that we, discussed in the draw. So this is the key, and this is the value. So we'll be discussing this part during the programming. So as of now, you can ignore it. So this key is going to be 0, and this value is going to be cow, 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 and panda, and so on for the first time. Now let us discuss exactly, what next needs to be done. All right. So what we'll be doing basically. So the very first input is basically this. This is the very first input. So we're going to follow an algo here. All right. We'll follow an algo which will lead us to the word count ultimately. So okay, split the value, by space, and it will generate a words array basically. All right. It is going to generate the string array or the words array. Assign 1 to each word. Okay. So these are the 2 steps as an algorithm that will be following, for each map call. So I'm repeating here. These are the 2 algorithms which will be following for the each map call. So how it is going to look like, right? So the very first value is cow, 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 and panda. So we have this first line, cow, 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 and panda. So what we're going to do is we are going to split these words, this whole sentence by space, and it is going to generate a character array like this. So after the splitting, it is going to look like this. And once we have got the value, right? Once we have got these values here, to each value, we are going to assign 1. So basically, it is generating the key and value 1, 1, and 1. If you look at the output here, what mapper is generating, it is generating another key value. All right. So, so you will find that mostly MapReduce applications work in a key value based data structures only. So if we follow these 2 steps for the first call of the map, we will end up with this data. For the easy understanding, I'll just write it this way. So the data is going to look like cow 1, and then it is going to look like cow 1, and panda 1. This is the output of the first map call after following the given algorithm. Now, once the first map call has finished, it is going to invoke the second map call. If we follow the same algorithm, we will end up with panda 1, panda 1, and cow 1. As you can see here, we have finished the second map call. Now we'll start with the third map call. Remember, the keys and values will be changing here in these parameters for each map call. For each map call, these keys and values will be changing. So as per the given algorithm, the output is going to look like bear 1, cow 1, and again bear 1. So finally, we have read all the data, and after implementing the algorithm or the business logic, we have ended up with this data. So here we can see that the key value pair is generating, the mapper is generating the other key value pairs. So I'm just removing this algorithm from here. Now this is the output. Now this is not the final output basically. This is the intermediate output. All right. This is the intermediate output of your mapper. Now there is one thing that I would like to bring to your attention here, right? So for the input, the mapper input, right? I'm talking about the input of the mapper. I'm talking about this particular data. I want you to observe the data types here. The data types, right? So what was the data type of the key? That was long writable. When we are talking about the input to the mapper, what was the data type of the value? That was text. So here, what you are seeing is basically the mapper's input key value pairs data type. Now, if we talk about the output which is produced here, if you look at the output here, the data, the key here and the value here, the key is basically of text data type, whereas the value is of int writable. So I'm not taking long writable here because by nature it is going to be of lower value. So for the memory efficiency or for better utilization of memory, I'm taking int writable here. So here, this is important for you to understand that in a mapper basically, you need to know what is the key value data type of the input, and you need to know what is the key value data type of the output of the mapper, right? So this pattern should be very clear with you when you are working with the MapReduce lifecycle. Now we have successfully completed the mapper phase, and now we'll be moving to the shuffle phase. Now what shuffle phase will be doing basically, it will be rearranging the similar words all together, right? Such as all the cow will be segregated, similarly the pandas and the bear. So that is the shuffle phase. And after that, this shuffle phase will be completed. Now the next phase that will be followed after collecting the similar type is basically the sorting phase. In the sorting phase, the data will be rearranged based on the alphabetical order by default and exactly based on the key. So after the shuffle and sort, the output is going to look sorted, and it is going to look like this. After shuffle and sort, it is going to look like this. Cow, and here we'll not be repeating the keys, we'll be repeating the values basically for the cow. But because it is sorted, so I think I've chosen the wrong one. It should be bear first of all. So bear, and this is the key, and the value won't be repeated. The key won't be repeated, sorry, and the value will be repeated like this. Now we'll have cow here, and the values will be repeated for the cow. So it is going to look like this: 1, 2, 3, 4, and 5. Now the panda will be repeated here. So it will be 1 and 1. So you can see here that we have shuffled all the similar keys and all the keys are sorted. So it is like B, bear, C, cow, and P, panda. This is how the output is supposed to look like after shuffle and sort. So here we have completed these two phases. Now these are automatic phases. This will be done automatically by the MapReduce framework, and we don't need to write any code for it. Now the next phase that will be initiating here is basically the reduce phase. Now once again, similar to the map phase, we will visualize a reduce phase as a reduce function. It is going to again have the similar parameters here, the key and the values. But here, this second parameter is going to be an array. Why is it so? The reason because this is the key and this is the values. So if you look at the values, we have multiple values there. So in order to store these multiple values, we need to have an array there. Now similar to the map phase, which I explained that for each line the map phase will be executed, similarly for each key value pair here, the reduce function will be invoked. So we have three different key value pairs. So for three different key value pairs, the reduce function is going to be invoked 3 times. For each call, this key and value will be changing. So in the first call, the key is going to be bear, and in the second call, it is going to be cow, and in the third call, it is going to be panda. So what is the business logic that we'll be following there? All right. So let me explain you here. This is how the reduce function is going to look like. You can see here we have got the key, and you can see here we have the values, and this is of iterable type. So iterable means basically it is going to iterate through a collection. So visualize this part, iterable, again iterable, again iterable. Now let me explain you here exactly how this is going to work. So the very first key value pair which will be used for the by the reduce phase is going to be bear and 1 comma 1 1. So the key is going to be bear and the values is going to be 1 and 1. Here we have a variable long sum which is 0. This is for containing the total sum of all the values here. Here we are running a loop over the values. Now this is going to fetch all the values into the val one by one. As we can see here, there are in total 2 values here. So this loop is going to run 2 times. In each iteration, the val will be 1 and this val will be added to sum. So once this loop completes, we'll end up with sum as 2. Now here, context.write is basically for saving the output. Now here, the key is bear and the value is the sum, which is 2. So you can see here, we have produced bear, 2 as the word count. Let us do it one more time to understand it more clearly. This time, we'll be invoking the reduce function for the second key value pair, which is cow and lots of ones here. So the key here is going to be cow and the value is going to be 1, 1, 1, 1, and 1. Remember that these assignments will be done by the MapReduce framework. So this loop is going to run a total of 5 times. is this loop is going to fetch all the ones into the val, and val will be assigned to the sum, and once this loop completes, we'll end up with the value of sum as 5. If you observe here, it is saving key and the sum. So this time the key is cow and the sum is 5. You can see here we have got the word count for the word cow, and the sum or the word count is 5. Similarly, we will call the panda key and the 111 key value pair. This reduce function is going to be called, and by following the same algorithm, same logic, it is going to produce panda and 3. Now, if you look at the complete output here, this is the word count that we have produced using the map and the reduce phase. Now, the final output is going to look like where 2, cow, 5, and panda as 3. So this was the expected output, and we have achieved it, finally finishing the reduce phase. So that was the explanation of exactly how the map and reduce phase works to get the expected or the desired output. Now let us look at a practical demonstration on how we implement this algorithms and the following logic in a coding form. So let us start with the practical. So this is a Cloudera virtual machine. In case if you're not aware of exactly how to prepare for this virtual machine, it is recommended that you please watch the previous videos. You can visit cloudera.com for downloading this virtual machine, and this virtual machine is running on VMware workstation. So here I'll be using the Eclipse for writing the MapReduce application, and I'll show you exactly how to proceed with it. So let us start by creating our first project. There are multiple ways of creating project in MapReduce. So here I'm using this Eclipse here. We'll go to File, New, Java Project. This is word count MR app. Let's click on Next and Finish. Now, to quickly set up, I have prepared the files already. So I'll be showing you the files here, which I've already prepared. So I'm just adding them directly here. So you can see that I've got the files here. Now, in case if you're doing it for the first time, you will be, right clicking on SRC to add a new file, new, and a class, sample Java file. So this is the approach of adding a new file in Eclipse, in case if you're doing it for the first time. Now you can see here that in my programs, there are some errors which are occurring. It is showing that there are some errors here. Now the reason why it is showing the errors is because it is not able to determine or identify the libraries here. Now these are MapReduce libraries. You can see here in different programs we have many libraries which are being used here. Some of them are Hadoop libraries and some are MapReduce. So the very first step that we'll do here is to add the reference of these libraries. Please look at the steps carefully in order to understand how to add libraries, Hadoop libraries and MapReduce libraries in your project. For that, we'll right click on the project, we'll go to build path and click on configure build path. This will open a dialog here. Then we'll click on add external jars. We will go to the file system. Then we'll go to the user directory. Next, enter the lib directory. Next, we will use these two directories as the source of the libraries which are required for writing and running MapReduce applications. So we'll add the libraries from both the folders one by one. So double click on Hadoop and the libraries are available to us in the form of jar files here. We will select all the jar files and we'll click on OK to add these libraries. Remember that I have only added the libraries from the Hadoop directory. Now let us add the libraries from the MapReduce library directory. So we'll click on the lib and we'll enter into the MapReduce directory. Select all the jar files, click on OK, and we are done. Once you complete the following steps, you can see that from the project, all the errors are gone, and now the project is able to identify the library references or the package references. Now the MapReduce application is divided into three parts. One is the driver. Uh, Driver is basically a file which is used for configuring your MapReduce application. Second is the mapper, and third is the reducer. Now, before we start with the explanation of the application, let me show you exactly how to run this application. And even before running application, surely I'll be explaining the code, but some part of code requires me to show you the execution. So I'll just take you to some steps here and then we'll come back to the code. Now, in order to execute this application that we have just prepared here, we need to export the jar file. The jar file is basically the compiled version or the compiled file of all the Java classes here. In the next step, I'm going to show you exactly how to export the jar file. We will right click on the project, we will click on export, and from the Java section, we'll select jar file. Click on next and select the jar location where you want to save the file. So I'm choosing desktop here, and the name of my file is, let's say, wc.jar, which is basically word count.jar. Now, if you click on next and next, here it is going to ask you which file among these files contains the main method, which is the public static void main method. So it is going to automatically detect and show it to you that this is the class which contains the main method. And click on the finish here and OK. Once you do this, you will see that a new file has been generated here, which is wc.jar. Now, this is the output of your MapReduce application. So basically, this is the file which will be executed, and this is the application. So this is the MapReduce application which will be executing. In order to execute this application, you need to open the terminal from here. And before you execute this application, you need to have some data with you. So the very first thing that we'll do here is that we will prepare the data. So Let us use the VI terminal for preparing a file called input.data.txt. Press I to enter into the insert mode, and we'll have the same data here. Press escape and press :WQ to save the file. Let us verify the data. So it is here. Now, in order to analyze any data or in order to process any data, that data has to be present inside the cluster. Now, the next step that we'll be doing is to push this data into the Hadoop cluster. And for that, we'll use the put command. We'll put it into the root, which is here. This is the root of the cluster. So the data has been successfully pushed into the cluster. Let us verify. So hdfs space dfs -ls / which is the root, is for listing the files and folders of your cluster. So you can see here input data.txt has been successfully pushed into the cluster. Now the next step is to execute the application. This application is there in the desktop, and right now my current location is not desktop. We can see the desktop directory here, so we will write cd desktop. So here is the file. Now what is the command for executing the MapReduce application? So let me show you the command for executing the MapReduce application. So it is Hadoop jar file input path output path. This is the syntax of executing a MapReduce application. So in the next line, I will be following the same command. Hadoop jar wc.jar. The input path is input data.txt, and the output path should be of the cluster, but the output directory should not be prior existing. So we'll write here my out1. So this is for specifying the output directory. Now this is from where we execute the MapReduce application, and I'm going to show you this execution in few minutes. Let us start with this code here, and let us understand exactly what happens when we execute the MapReduce application. So the very first program that is going to run is the word count.java, because it is a driver file and it contains the main method. Let us start with the explanation of exactly what is happening in this MapReduce program. So once we hit enter, it is going to start from the main method here. Now these command line arguments will be stored in args. Now if you recall your Java concepts, you will remember that args, this string array, is for storing the command line arguments. So if I tell you clearly, args0 will be containing the input path, which is exactly /inputData.txt. Similarly, args1 will be containing the output path, which is exactly my out1. Now, if the length of your args array is not 2, it means that the user has entered the invalid sequence of values. So the length has to be 2. That means we are confirming that there are input path and output path existing. In case if the length is not 2, that means either one of the path is missing or there is some extra input. In that case, we are just printing a syntax here and we are terminating the application. Let us assume that that there is no input there is no error in the in this program, and the length is exactly 2. So it will proceed further, and here we are creating an instance of the job class. Now in MapReduce, an application is called a job. So here we are creating an instance of a job here to configure the MapReduce application. This is the entry point of this application. This is the name of the job, so it can be anything. So in our case, it is word count. Here, as I told you that this is a driver program, and driver program is for configuring the job. So here we are configuring the input path. So set input paths is a function which is used to configure the input path, which will be fetched from the args0, which I explained you here, that it is going to contain the input path. Now file input format is a class which contains this function, and what we are doing basically, we are configuring that this job is going to read the input from array 0 index. Now here in the next line we are configuring the output path. So file output format is a class which contains set output path function. What we are doing here, we are configuring this job instance and specifying that whatever the output is going to be produced by this job will be saved at this location args1. So if you remember my explanation, args1 is containing flash out1. Now the next step is to set the mapper and the reducer. Mapper is for computing and reducer is for aggregation. Now, it is not necessary to create a separate file for mapper or separate file for reducer. You can code the mapper and reducer in the same file. But to divide the code complexity, we can follow this approach of creating the mapper and reducer in a separate file. Here, a wait for completion is basically a function which is used for initiating or starting a job. Now, once this call executes, it is going to start the job, and the very first step will be the mapper. This is the mapper. If we look at this parameters here, if you remember this section, just give me a moment here. If you remember this section, so this is the same parameters, right? Long writable, text, text, int writable. So what these are? The data type of the input and the output key value pairs. If we remember the explanation, for the data, this map function is going to execute for every key value pair or for every line separately. This is the key which is going to contain the offset, and this is the value which is going to contain the whole line. Let us assume that the value is cow, cow, panda. Now this value will be converted to a string and will be stored in line. Now this line will be splitted by the space here, means the non-word character, which is a space, and is going to store in the word. So if the length of the word is greater than 0, this is going to write word and 1. So in the very first iteration of this loop, it is going to write cow 1. Second iteration, cow 1. Third iteration, cow 1. And fourth iteration, panda 1. So if you observe here, it is generating the key value pair. Once all the key value pairs are generated successfully, this intermediate output will be forwarded to the reducer for aggregation. Let us move to the reducer and let's see how this reducer works. Now this reducer is containing the reduce function. This reduce function is going to execute for each key value pair. Let us assume that the key value pair that we are executing is panda 1 1 1. Let us assume that this is what we are going to execute. Now the key will be panda and the values will be 1, 1 and 1. This is the word count which is 0. This loop is going to extract all the ones from these values and it's going to store inside the value variable. Now this value will be added in the word count. This loop is going to run 3 times and word count is going to be ending with the value of 3 as the sum. Now here, context is basically an object which is containing the job information. All right. Context is an object which is containing the job information. Now this context is going to write the output, and what is it is going to write? It is going to write key and the word count. So it is going to produce panda and 3. For the other key value pairs, it will produce, let's say, cow 5 and bear, let's say, 3. So this is how the reduce phase is going to work. So just to give you a summary here, this is the driver program, which is for job configuration, which is used to specify the input path, output path, mapper file, reducer file, starting the job. Mapper is containing the business logic for generating the key value pairs. And all the key value pairs which are generated by the mapper will be forwarded to the reducer for aggregation. Now let us execute this application and let us see how this executes and how we can see the output. So here I have initiated the execution. It is connecting to the master. It is reading the output, and here we are provided with this URL. If you click on this URL, you can use this browser application to monitor your MapReduce application. So you can see here, this is a monitoring tool provided by the MapReduce framework, and this is for monitoring what is happening inside your application. So it is providing you with various details like user name, application type, state, and the logs, which are very important. In case if you are facing any errors or difficulty, you can check the logs and various information provided in the logs. All right. So if I show you the terminal here, okay. So look like there was some error in the application, so I have corrected it. So let me show you exactly what was missing in the application because of which it was not running. And we were missing these two configurations in the driver program. So this is for specifying the data type of the key and data type of the value. Make sure you add these configurations in the driver program. So the output which is going to be generated by the reducer, it is going to be a key value based output where the key data type is going to be text and the value data type is going to be int writable. So let me give an example here. Let's say panda 5. So this is the output which is going to be generated by the reducer. If you look at this output, the key is text and the value is integer. All right. So these two lines here are for configuring the data type of the key and the value of the output which is generated by the reducer. So let us export this jar file once again, and you have to follow the same steps. So following the same steps here and finish. Once you have saved your program and exported the jar file after making the necessary changes, we will execute the program once again. So now it is connecting to the master. It is going to read the data, and now it is going to initiate the map phase. You can see the percentage completion here for the map and reduce phase both. And here the execution has completed successfully. We can see here this is the total number of this is the total size of output which is generated, and the output is saved in my out1. So we will check this directory hdfs dfs-ls slash my out1. So this is for checking whether it contains any output file or not. So here you can see there is an output file here, which is part-r-5 times 0. So we will print the content of this file by using the cat command hdfs dfs-cat slash part-r-5 times 0. Oops, my bad. It is supposed to be my out1 slash. So here you can see we have successfully calculated the word count of the given dataset. Now the same algorithm and the same application can be easily implemented on the bigger datasets with some no or minor configuration changes. So that was all for today's session, everyone. I hope you liked the video and the explanation of the MapReduce application.